This video proves that thrust is not possible in a vacuum.
Alright everyone, welcome back to Cody's Lab. So as you can see, we're using the vacuum chamber once again, and I actually have a little feather right there, as you can see, suspended in front of a 12-volt electric fan. See, I got the batteries, a pressure gauge, and everything in there. To turn it on, I have a little tilt switch that says magnetically controlled. You can see when I turn the fan on, it blows the feather all over the place. This is, of course, at atmospheric pressure right now. So, I want to take this down to Martian conditions. You might have noticed the Martian reference over there. The first thing I'm going to do is add a little bit of dry ice to the chamber, just so that the atmosphere gets replaced with CO2. So now I should have a CO2 atmosphere, or at least it'll create one. And now we're going to suck out all of the air, or at least most of it, down to the point where about between 4 to 6 millimeters of mercury, which is, of course, the pressure on the surface of Mars. So let's plug in the vacuum pump. And there we go. So since we're at Martian air pressure, let's unplug the vacuum pump and let's turn on this fan. Now place your bets as to what's going to happen to this feather. Now the fan's only going to produce maybe 10 miles per hour worth of wind. On the surface of Mars, the fastest recorded wind speed is about 70 miles an hour. But let's say the superstorm in the Martian had wind speeds of 200 miles an hour, 20 times what we have here. To compensate for that, I imagine the feather is about 20 times easier to push over than a spaceship. So let's see what happens. Okay, fan's on. And the feather's not moving. In fact, let's zoom in on that.
This second experiment proves that combustion is not possible in a vacuum.
So how about something that has its own oxidizer, such as gunpowder? See, this is a mixture of charcoal, sulfur, and potassium nitrate. When heated, the potassium nitrate gives off oxygen, which the sulfur and charcoal uses to burn. So I've got a little bit sitting in there. Let's apply the laser goggles, and let's light it off. First in the atmosphere, and then in the vacuum. Okay, as you can see, it produced lots of smoke and burned rather quickly. Most of the air is now gone. Let's see what happens. The gunpowder did not ignite. I saw some smoke coming off of it, so I know it burned a little. Let's try again more in the center of the pile. And that's it. The gunpowder does not burn. And so I'm going to be burning some rocket candy. This is a mixture of sugar, potassium nitrate, and iron oxide. This is used in amateur rockets because the ingredients are readily available and the amount of thrust it produces is quite high. So let's light this on fire and see how it does. So this is in Earth atmosphere. As you can see, it burns rather rapidly, producing a little bit of thrust even. As you can see towards the end, it moved it around. So now let's try it inside of a vacuum. No ignition. That's interesting. I did see some little poofs as it tried to burn, but it was unable to sustain itself. So even when it's in one solid piece, it can't chain and continue burning. So I've let a little bit more air back into the chamber. Let's see if it'll burn now. That's a no-go on burn. Wait. It's kind of smoldering. And it's out. Acetone peroxide in the atmosphere in 3, 2, 1. Yes, that's a little bit more volatile than gunpowder is. Acetone peroxide in vacuum in 3, 2, 1. It still didn't burn.
So essentially, what we have here is solid evidence that space travel is fake. Therefore, the Mars rover is a complete hoax, and this Mars simulated environment on Devon Island is where they fake Mars rover footage.